Yes, sir. Live, right. Good evening, everyone. Welcome to day two of MLRW series brought to you by IIT.ai Club from IIT Guwahati. Today, our esteemed guest is Ramit Sawhney. He is the engineering manager at Tower Research Capital and a researcher at Georgia Institute of Technology, Mohammed bin Zayed University of AI, and the University of South Carolina and the University of Marburg. He was honored as the number one first author worldwide to have the most significant number of top AI NLP papers in 2021. Today, he will discuss and enlighten us about NLP and AI in finance. And Sawhney, welcome to the series.
Yeah. Thank you, Pushkar, for the very nice introduction. And thank you, everyone, for taking out the time, and to IITG.ai for the opportunity. I think it's definitely a great platform to speak to many students or professionals like me who would either be a beginner or just starting out with their journey in terms of AI or finance or both, or even for experts. So just add a little bit to my introduction and then give a sense of what sort of agenda we can have. And Pushkar, feel free to put in your suggestions at any point. But
Yeah, sure, sir.
a very quick introduction about me, apart from all the good things that Pushkar said, is I graduated in 2018. When I started in 2018, I didn't know anything about research, nothing. So no machine learning, no AI. We didn't have any ML or AI societies in college. So it was all self-learned, I guess, in some way or the other. And the main reason why I say that is because I feel even today, a lot of this can be done on your own. So just knowing the right amount of things, we're in a place where the amount of information that the internet has, the ML community has put out there, it's very easy to pick up NLP, AI, or even finance on your own. So my journey started in 2018, and over these last 5 years, I spent time reading research papers, collaborating with different folks, and most recently, I think in the last 3 years, my focus has primarily shifted towards NLP and finance. And there's a reason behind that. So I think over the last couple of years, with crypto, NFT, and these sort of new asset classes coming in, and the surge of social media that's come into play, it's become very relevant for researchers to move beyond conventional models like just looking at price time series, etc. And that was my motivation of getting into AI research. Back when I started it, there was no plan really per se in terms of I want to achieve X, Y, or Z. I think it was something that I enjoyed, and hopefully through the remainder of this session, it's something that you'll also find interesting. But it's something that I ended up enjoying and did not know that I would get so engrossed into it. But 3 years after that, somehow I'm still very interested in it. And what I'm thinking for today is to kind of tell people or walk people through what the beginning stage or thought process is and how that evolves all the way into a research paper. So for me, the end goal was always try to publish a research paper because that shows that my ideas have merit, as well as some ability to tell the world and share a good idea when it comes out. Today, the paper that I'll talk about in some time has been one of my most cited papers. It's a paper from 2020 and marks the first ever paper I did in NLP plus finance. And it today being one of my most cited papers is obviously a big celebration for me, but more so as a very important learning for people like me or people like you who are listening, that you can start from practically anywhere with NLP and finance and sort of have a good trajectory in terms of building an AI career, both in the industry or as well as in the research domain. So how do we do this, Pushkar? Do you want me to just start presenting, or do you want to ask like questions? Is there a format, however?
We can start with the presentation and then we can keep questions.
Okay, sounds good. I'm going to try bringing up my screen.
Yeah.
So hopefully within 30-ish minutes, we can wind up and then we can take any questions, etc. So give me a sec while I... okay, give me a minute. I think I need to download these slides and then upload them here. So figuring that out. Just a sec. I'm going to try and be very quick. Okay, so the slides are uploading. While they upload okay, they have uploaded. That is fast already. So should be up in like 20-30 seconds, hopefully. While they do upload, I do encourage everyone who is chiming in, put in any questions that are there. There's no such thing as a question that's too difficult or too simple. I feel like even if you don't know where to start, these questions don't need to be about necessarily about NLP or finance or any of those things. It can very simply be anything related to building out an AI career, research, an industry career, or sort of any of those things. So at any point, just feel free to put those questions in, and we'll take them towards the end. Just to quickly confirm, my screen is now visible, right? You can see
Yeah,
the.
yeah, yeah.
Okay, perfect. So while the name of the paper might sound like a very heavy paper, it's a very, very light and simple paper with three very simple ideas that I'm hoping to convey through this session. It's a paper that was accepted in EMNLP 2020. So it's one of the biggest NLP conferences that takes place every year. And interestingly, ever since I published this paper, every top NLP conference that has happened, we've published at least one, if not many, NLP plus finance papers. One of the biggest feedback that came in during both the paper presentation for this paper as well as when this paper was accepted is that NLP in finance has been a very small niche. Not many people do it. And there are reasons that not many people do it. It's very nascent, it's very new, it's not necessarily so evolved that it could be used in the industry. But that has obviously changed over these 3 years. And the evolution of that thought process and the core ideas that came out in this paper today have been used by over 50 other researchers, has been cited more than 50 times globally. And that's kind of the idea that I want to put across through this paper. So without further ado, here's a quick introduction to what this paper and talk is going to be. So the first is we'll talk about a task called stock movement prediction. It's a challenging task in the sense that it's not a very easy task for humans or natural language processing or any machine learning models to try and do. So without getting into too much detail, stock movement. So I'm sure most people would know what a stock is. A stock is basically something that represents ownership in a company. For example, today, Google, Microsoft, Apple, all of these have stocks, and a stock has a certain value. The value of this certain stock represents how much people are willing to buy or sell that stock in the market. And the price of that stock fluctuates very, very frequently. In fact, to the order of nanoseconds today. And as the price of a stock increases or decreases, traders like you and me or big companies which have algorithms running try to predict if that stock's price will go up or if that stock's price will go down. And a very simple thought process is, if I think the price of a stock will increase in 5 days, maybe I should buy it today and sell it after 5 days. The price increase that has happened will basically be the profit I make. So it's a very simple game of making money. Now, as simple as making money sounds, these stock prices are influenced by a lot of things. For example, historical price. For example, if an earthquake happens, if it's rainy weather, if it is sentiment of the market, if it's even as simple as a human interaction like US elections, every single thing will influence the price of a stock. And what we're going to try and do here is we're going to try and see some different types of alternate data that have come up in recent years in ML and AI, such as natural language, which is basically the text that we use to talk in today, graphs, general directed acyclic graphs, bidirectional graphs, and then standard numeric features. And we'll try to discuss a neural network architecture, the architecture that we came out with in this paper, and see how that learns to predict stock prices. The whole idea is going to tie up with something called the efficient market hypothesis, which basically says that anything that happens in the whole world, anything and everything, is captured in the price of a stock. So, for example, if I'm trading Apple stocks, it is likely that if a storm hits in, say, one of the countries where Apple has a production facility, even that storm can have the ability to bring down the price of the Apple stock. So, efficient market hypothesis simply says that the price of a stock is implied or sort of affected by any phenomena that occurs or anything that happens in the world. And we'll try using that to decide how to make the neural network architecture of our model. Towards the end, because that's always what stock movement prediction is about. We'll try discussing some real world simulations that we did, which will show that what kind of data or what kind of neural networks or techniques in ML and AI lead to a better or more profitable kind of strategy. So at the end, the best way of checking, or for those who ever want to do an ML plus finance paper, the best way of seeing how good your model is to, or to try and publish it, is to try and see how much money it's going to make. And that's what we're going to do at the end of this, is going to go over and see, on top of some benchmark data sets, how well did this model do and what kind of money did it make. So that being said, let's start from the absolute basics. So, and again, if you've heard of these concepts, bear with me or feel free to correct me if there's something that's incorrect. As and when we take the Q&A towards the end. But in very simple terms, the stock market provides opportunities for investments and profit generation. So many of us today, even students today, I think use apps like Zerodha in India, or people who are abroad would use many ways to invest their money. Some of us do that in very simple ways, like fixed deposits, like our parents might have bank FDs, etc. Some of them invest in mutual funds. Some people are doing stock trading. More recently, some people started doing crypto. The gist of it is all of these places where you buy and sell something includes the stock market. And the stock market, in very simple words, gives us an opportunity to make more and more money. As of 2022 or 2023, I don't have the exact stats, but as of 2020, you can see how the growth of the stock market has gone. Today, I think it's reached a point where it's over 100 trillion again. During COVID, there was a dip, but again, over time, we've seen that rapidly increase. However, as more and more money enters the stock market, it's also important to keep in mind that there are many more people who enter the market, and the competition to make money is very difficult. So when you're trading in the stock market, you're not just trading with every other person like you. You're trading with automatic algorithms and very big companies like hedge funds, etc. And all of these, the common goal for everyone is just to try and see when the price of a stock will increase or decrease. And when that happens, you try and make a decision of buying or selling. That being said, like I said before, prediction is hard. It's not an easy task. The market changes very, very frequently. You might have seen things like a small news comes on the TV, someone posts, like Elon Musk posts a tweet on Twitter, and markets will change by a lot. They'll drop by billions. People will lose millions and millions in seconds. And the reason for that is that a normal human will get influenced by anything. And that way it becomes very difficult for humans to keep a track of everything. Like, I can read the news, but how many things can I keep a track of to accurately predict whether stock's price will increase or decrease? And that's kind of where AI comes into the picture. We're dealing with terabytes and petabytes of data, which we need to ingest very, very quickly to make quick decisions to make money. That's the whole game. Now let's take another very interesting example. Let's forget everything I discussed so far, and let's think of this tweet that came out on December 12th, 2016, where Donald Trump says that a certain program and its cost is out of control. Billions of dollars can be saved, and then on military, etc., after a particular date. When you read this, you just get a sense that, okay, it's one of those texts that comes on social media, like, almost any text that comes on social media. No major impact, no major influence. Then you see some more text coming in. So someone else at this point says, after Boeing, Lockheed Martin. So Boeing and Lockheed Martin are two big companies that have public shares. Boeing, I'm sure many people would know, are the ones who make the airplanes, etc. And they say, there go the shares. And then this is speaking of this. So basically, as what I'm trying to convey here is, there is some conversation that's going on, which is not necessarily about a financial market or any stocks or anything, but there's a discussion of some companies and some government schemes. And then you see on December 13, someone says Lockheed Martin F-35, story of a failure, parts are way overpriced. More or less what's happening is, there is a company called Lockheed Martin which provides some parts for military, etc. And once Donald Trump started talking about it, many people started discussing its failure on social media. Now you must be thinking, how did the topic of this talk shift from stock prices and NLP and finance all the way to some military and tweets that are being made by Trump? And the whole point that I'm trying to convey here is what will come up next. So what happened on this particular day, within minutes, the moment that this tweet came on December 12th, 2016, the stock valuation, the market capitalization. So basically the company Lockheed Martin lost more than $5.8 billion within minutes. That's the impact that one single tweet had. So basically, Donald Trump saying that this company is not doing so well, blah, 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 leads to a massive, massive, massive drop in their stock price. Obviously, a loss of $5.8 billion is a huge amount and changes or moves economies. And that is basically what is a good example of how stock prices can get influenced by anything. Looking at it more, you'll see on December 12th specifically, the more people start talking about Lockheed Martin, the impact changes more and more. You can then see specific tweets, especially the one that's of Donald Trump, or this other one, which is in a slightly darker blue border, which basically emphasize again that the more that social media sentiment comes up, the more likely it is for people to get influenced. Think of it as another example. Today, anything that comes up on social media, that's basically one of the biggest areas or platforms through which we gain more and more information. Almost everyone, all of us use social media on a daily basis. Frankly, I think I spend way too many hours on Instagram for my own good every single day. But when you do, you are thrown information constantly from all of these different social media platforms, which influence you in one way or the other. Sometimes it's a marketing thing, but a lot of times it's a stock market thing. The core gist here is that tweets, as and when they come, especially in the sequence that they come in. For example, if someone says, Donald Trump says a certain company's parts are too expensive, then 5-6 other people again say that they're too expensive. And that keeps repeating. It gets embedded in your mind. Similarly, stock markets react like that. If someone big today says, I think there's another example. At one point, Elon Musk had said that Twitter's stock price is way too high. The moment that happened, Twitter's stock price crashed drastically. Then more and more people started saying it, and it became a domino effect. So what I'm trying to convince you here about is, first, tweets or stock text that comes about it has a very, very large impact on financial markets. And it's something that until 2018-19, until when BERT and these NLP models had not become very popular, no one would look at. So people were missing out on a lot of crucial NLP related techniques and data which can be used for stock price prediction. Because in this case, it is this text which is basically triggering prices to change. Now, continuing here, let's take a slightly different example. So here we're looking at the stock price of another Elon Musk company, Tesla. And you'll see that this is the stock price of Tesla around April 2018. This is roughly how it's fluctuated over time. At this point, the example that I was talking about, Elon Musk says Tesla goes bankrupt. At this point, you see a major drop happening. This is again similar to what we discussed before. It's billions and billions of dollars in a valuation loss. At this point, another company, and this is, I think, common knowledge, but just to share again, PayPal, another company that Elon Musk owns, at that time, it also observes a very similar drop. In fact, if you were to look at the price correlation of these time series, you would see around this time frame, the one that's circled, you would see the price correlations are very similar. The reason for that being that most people realize that when Elon Musk says this, maybe he means that for all of his companies. It's kind of like saying that tomorrow, if I say one of my companies is going to go bankrupt, it's very likely that people will think my other companies are also in danger. So what I mean by that, another core fundamental assumption that finance theory has made over the last years is that every stock operates independently. So people think that, oh, this stock's price has been increasing over the last 10 years. So let me invest in this stock and the price will increase again. But a very fundamental gap in that understanding is that stock prices are influenced by each other. For example, if when TikTok got banned in India, it's a very specific example to India. At that point, Instagram decided to go into Reels, and it made a lot more money as it did that. So they are influenced by others, or when a certain company's stock goes down. For example, if Google is not doing very well in, say, the mobile pixel market, it's very likely that Apple's iPhone prices will jack up or the stock prices improve, etc. It's a matter where there is a relative comparison across different stocks. At this point, Tesla also fired 9% of their workers. And the moment it did, you can see that the stock price again increases. This has now nothing to do with how Tesla as a company is doing inherently, but it basically means that people started saying, okay, maybe Tesla is going bankrupt, so they fired a bunch of people, and that helps increase their costs. In fact, if people are now keeping up with the recent tech layoffs that are happening, you'll also see that as more and more companies do tech layoffs, when they announce that these tech layoffs are happening, their stock prices increase, which is another example of how stocks react to different things like tweets or different stocks behavior. At this particular time, you would see PayPal stock also reacting in different ways. You'd see basically common correlations happening where people think that if Tesla is firing, but PayPal is not firing, so maybe PayPal is not being as cost conservative. Again, as you'll see, you can see the more and more common patterns. When Tesla observes another big drop, so does PayPal. And similarly, when PayPal rises up, so does Tesla. The common correlation that we're trying to make here is that stocks are not independent of each other, but rather correlated to each other. And that is another thing that existing financial models have not factored in over years. And that's what neural networks, specifically graph neural networks, have started doing. So that being said, let's talk a little bit more in terms of math and NLP here. Let's try and formulate the exact problem we are solving and simplify it. So our problem is very simple. It's a binary classification problem, which basically says, given a stock and a particular day, I need to tell that tomorrow, will that stock's price increase or decrease? It's as simple as that. Now, what you're seeing on the screen is just a fancy annotation of that. YT here basically means the label. 0 means that the stock's price reduced. 1 means that the stock's price increased. And PC, D minus 1 are just notations which, just mathematical jargon which helps you understand what we're trying to do. And what we're going to do is we're going to look at data from, for every single stock, I'm going to look at its historical stock prices. I'm going to look at all the tweets that people have posted about it online. And I'm going to look at all the relations that it has with different companies, build a neural network using that just to predict if that stock's price will increase or decrease. And as I make those predictions, I'm going to try and run a strategy, a trading strategy, which will decide when to buy and sell a stock based on this AI model, and then try and make me money. And at the end of this whole presentation, we'll see how much money did it actually make. Now, what you might see here is a very, very fancy or complicated neural network architecture. I would say we shouldn't get too much into it. We should only look at it in a very simple way. And I'm going to try and break it down as easily as possible for you. And you're going to see it over time. Just give me 1 sec. I'm going to stop for 1 sec. I think need to change one quick thing. I think we've had some slides which are getting skipped over. So I just want to take up all the slides. Okay, fine. It's all loaded. So what I'm going to do is first show you a very high level view of this existing architecture, help you understand what we're doing, and then we're going to break into the different parts of this neural network architecture. So to start with, we'll see price related information. So basically for every single stock, you have some prices, like yesterday the stock price was 10, a day before it was 9, so on and so forth. So it's basically a time series of price related data. And similarly for text, every single tweet, like I showed before, the tweets that came from Donald Trump and many other people, all of these are basically sequences. So we take each of these sequences, pass it through an encoder like an LSTM or any recurrent neural network that you can think of, apply a temporal attention on top of it, basically to amplify what are the most important parts of this time sequence, combine them using a bilinear transformation, which is nothing but just combining two different vector embeddings, and then feed it into a graph. The graph here is basically what I showed before. So companies like PayPal and Tesla are related because they have the same owner. So we mine a graph of different companies. It's a publicly available graph, and we feed that into a graph. These embeddings are then fed through a graph attention network. And again, I'll share the paper with everyone so that they can read more technical details of it. I'm not going to get very mathematical here. But the graph attention network then does a prediction for every single stock. And the end outcome is for stock 1, the price reduced. For stock 2, the price increased. And just the binary classification output that we discussed. So now breaking down the individual parts, let's look at the price encoder and temporal attention. So first things first, the historical price of a stock is a very strong indicator of its future prices. Kind of like, in the stock market, people often say history repeats itself, and sometimes it does. So similar logic here. To predict the price of any stock, we want to see how it has historically reacted. For example, if you were to buy a stock tomorrow, you will try and wonder that if I was to, if Reliance's price has been increasing over time, there must be a stock that does well, and maybe it will increase over time. These stock prices, as you can see here, day t minus t, dot, 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 day d minus 2, d minus 1 are basically the different prices at every single day. Here, PC means the close price, the price at the end of the day. PH means the highest price it had throughout the day. And PL means the lowest price. So we take a three-dimensional vector or array, which has these. And for every single day, we make a time series and we feed this into a GRU, a gated recurrent unit. So it's a very simple form of a recurrent neural network, which models a sequence. On top of this, we put something called temporal attention. Again, not getting into the specifics of any of the maths, but temporal attention basically says I'm going to look at some of the most important days where some kind of price prediction is made. For example, some days stock prices or movements in the world are more important. Some things are more special and those need to be factored in. So temporal attention does that. And at the end of the day, I get a single vector called the price information feature vector, QT over here. And this is what I'll use for my feeding my model further. So what I've done so far is I look at the historical price of every single stock over time, see how that has changed, and feed it to an encoder. Similarly, very similar architecture. All I'm going to do is I'm going to look at tweets that came out and encode every single tweet into a time sequence, and then again create a new social media vector called CT, basically a combined representation of all the tweets that have come in a historical time frame about a stock. At this point, it becomes important to understand how am I encoding my tweets. Now, given this paper was written in 2019, we didn't use something like BERT. We use something called a universal sentence encoder. It's an older version of BERT, or like a contextual embeddings, but older. You can use anything to convert your tweets to text. Basically, that's the part where NLP comes in. Every text needs to be converted to a numerical representation. And that is done through word embeddings or sentence embeddings. Today, those models are BERT, ChatGPT, etc. Back when we did this paper, it was use universal sentence encoder, fast text, glove, word to vec, etc. So we convert every single tweet and social media text into numerical embeddings, and then we have a sequence of these embeddings. So just going back over here, yes. So just going back here, you'll see there are 6 tweets that I show on my screen, and we have them day-wise. We feed each of these tweets, convert them into a numerical representation, like a 2-dimensional vector that comes out of BERT, and then feed that embedding that comes out of BERT one by one in a sequence through another gated recurrent unit. So just building a sequential embedding. And the end culmination of all of that is for me to have a sequential embedding that represents the entirety of social media text, or like the text embedding that has come into play so far. Now, the next part, I spoke a little bit about graphs. So we're also going to talk about how do you make these, how do you capture relations or mathematically model the relation between any two companies. So think of a graph, a regular graph that you do in data structures and algorithms. Every graph has a bunch of nodes and edges. Here we say that every stock is a node. So for example, Berkshire Hathaway and Wells Fargo are companies, Amazon and Apple are companies like that. And then we say that every relation between these two companies is going to be an edge. So we say, for example, Berkshire Hathaway owns Wells Fargo. So those two are connected in a graph. Similarly, we say that Amazon and Apple are both partly owned by one of the company's State Street Corporation. So they also must be related to each other in some way or the other. We go on Wikipedia and mine relations for every single stock that is there online, and we generate such a graph. So this is a very standard bidirectional graph which says that these two companies are related to each other. The next concept, and again, we're not going to go into this in detail, but also focuses on the concept of attention. So we say that certain companies or certain edges in a graph have more weight, kind of like a weighted graph, or have more importance than other edges or graphs or nodes, etc. And that is done through something called graph attention networks. Again, for those interested, you should definitely read the paper that I've put as footnote over here. It's a very, very, very famous paper and a very good technique to learn. In fact, it's one of the most common things that most companies and researchers are using today. So the graph attention network, all it does is it takes information that you have encoded in each of its nodes, propagates it across the entire graph, and gives you new embeddings. So what we've done so far in this model that we presented, I encoded all the price historical numerical information into some vectors. I encoded all my tweets into a text vector, and I combined that and fed it to a graph attention network. The graph attention network then leads to some predictions, and using those predictions, since it's a binary classification task, we get some metrics like an F1 score, accuracy, and MCC. For those of you who don't know MCC, it's called Matthews Correlation Coefficient. It's a very good way in terms of knowing how good a model's prediction is. And honestly, ever since I've seen MCC, I question almost every single research paper that uses F1 and accuracy and does not show MCC, because it's the most accurate metric of showing any classification task. So just advice for everyone, use MCC where you can. Most of the top tier classification papers will use it. And again, I leave it as homework for people who are interested to see what the formula is and why is it better and those sort of things. So the core crux of what we did in this table here is, so F1 accuracy and MCC, the higher the better, and the darker the shade of green for highlighting, the better the result. So we looked at a couple of baselines. These are very famous baselines that were very popular back then. And we did this on many, many different data sets. I'll go over what those data sets were. But we used US's S&P 500 index, China's A shares. So we basically tried many different stock markets, and what you're seeing is the combined performance. So there were a couple of models here. Stock fund technical analyst is basically the closest approximation to how a human would predict if they only looked at the historical stock prices. Then fundamental analyst is another way in which humans try to capture the performance of a stock. So fundamental analysis means they're not going to look at the company's past performance number wise. They're going to look at the statistics like how old is it, how much money does it make, and those kind of things. And the hedge fund analyst is basically a combination of the technical and fundamental analyst. Then there are a couple of other baselines. These are again very top tier papers from AAAI, ICHKAI, etc., which we compared our work with. And then the last MAN SF, which is this paper, is the one which stands for Multimodal Attention Network for Stock Forecasting. These are basically the performance metrics for it. Again, the paper highlights most of this in detail. All I'm trying to say is we compared across a different bunch of top tier baselines across many different top data sets and found that the performance was better. The next is going over an ablation study. So let's forget the attention map that you see on the right. Just look at the table on the bottom. You'll see that we broke down our model into different components, and you'll see how on adding things over and over, the performance increases, both for F1 and MCC. So if you just use your price modality, just price. So this is what people were using historically, what the best ML and NLP papers were using so far. Just using price gives you an MCC of 0.02, which and 0.000 basically means that the model is doing a random prediction, and an F1 score of 0.52. Then as you add text, you see a drastic improvement in the MCC, meaning that stock prices are influenced by text that comes on social media, like tweets. Another good example of that is, I don't know if many people would know this, but sometime around 2020, I don't remember the year now, 2021 maybe, or 2022 maybe, I don't remember. There was a huge thing called the GameStop crash. It was very big in the news. And there was a company called GameStop, whose stock kept crashing. And there are many hedge funds which were worth billions of dollars that all failed. They all lost tons and tons of money. And it's a good thing to read, but when they lost all the money, some of the key reasons where they lost all the money was because most people were using Reddit. There's a stock market subreddit called Wall Street Bets, where people were discussing how they will bring down certain companies' stocks. And it was all social media that was driving big movements in the stock market and led to a huge decline in stock prices. At that point, there were very few companies that were using NLP for stock price prediction, but the ones that were using it were making tons and tons of money. So this is just another elaboration of how that works. Then as you start adding more and more things, if you add the graph to the price, you see an improvement from 0.002 to 0.093. As you add graph and text, you get more improvement. You add graph with attention with the price, you gain more improvement. And finally, if you combine everything to bring the model that we made, and that's kind of how we made our model, by playing and trying many different parts, as anyone should do who's doing ML research. You'll see that as and when you combine more and more different parts and carefully select how your model should be designed, you start getting a better and better model. Now, proceeding further, there is another metric. I think we've not given actual dollars here. We've given a metric called Sharpe ratio, and it's the biggest and most commonly used metric for defining profit. So a Sharpe ratio, positive Sharpe ratio, basically means you are making profit. You can see profit trend shown here. So dark blue is Man SF and all the baselines that we are comparing with. So we compared with many different models, and we ended up learning that Man SF does really well in terms of Sharpe ratio, earns a lot of money. And the reason why we use Sharpe ratio instead of just profits is because the Sharpe ratio also factors into account how much risk you're taking. So effectively, the core goal with any finance plus AI model is not just to build the most profitable model, it's to build the most profitable model that takes the least amount of risk. Because it's very easy to put more and more money and put more and more money at risk, but you'll only be able to do best when you're taking a more conservative approach, which this ML model sort of tries to achieve. Coming towards the end of what I wanted to present. So what's next? What's next in finance, ML, NLP, and AI? And what are some directions where the audience or people who are interested that they can take? The first is there are many more types of data which affect stock prices. It's not just tweets or social media, but it's things like financial news articles, things you read in the newspaper. Today, it's even Instagram reels, LinkedIn articles, company earning calls, etc., which people can use and people have started using. The next thing is also to understand something called the cold start problem. So it's a very common problem in recommender systems, which basically says that how do I do recommendations for someone who's never used my platform? And that's something that comes up in finance. How do you do stock prediction for a stock which doesn't have any data available today? For example, if there is a new stock that comes up today, how does a company decide if they should invest in it or not? The best way is to try and think, how do I extend such a model where there is no data? So that's another interesting problem statement. And then the last is, currently what we're doing is with Man SF, we need to solve one market or one exchange one by one. It's not a multilingual kind of setup. It takes only tweets in English, etc. The NLP problem here would be to try and investigate or look into, building models that are more multilingual, which is where the whole NLP world is going anyway. BERT came out in 2019, then multi-language BERT came out later. Today, ChatGPT is also extending to many more different languages. So as with any NLP problem, one of the key problems to solve is to grow to a cross-market and cross-language kind of spectrum. So yeah, that's the 30 minutes that I promised you right on time, where I wanted to go over everything related to at a very high level. But again, please feel free to read the paper. Some core ideas, which I'll just summarize in the last minute that I've kept for myself. So stock markets and finance have moved beyond just looking at prices or historical methods. Today, people use social media and alternate streams of data from everywhere, all the way from social media, text, Reddit, videos, company articles, etc. And people have started using graph neural networks to achieve all of these things. So going forward, if you're ever interested in finance and NLP, try looking at some of these techniques. And there's a very promising scope and a very encouraging community that wants to see more of these papers and has a very bright research path ahead. So that being said, again, thank you everyone for your time. And again, if there's any questions, any comments, I'm more than happy to take those on.
Yeah, so we can have a few discussions. That was a really insightful talk as such, and thank you for saying that as well. Saying for the content that was really amazing. Thank you, sir. And we could have some more discussion on it as well. We have a few questions, as in, like, could you discuss temporal attention a bit more in detail? Like,
Sure. So
the
I'll just
architecture
go
that
back to that slide there. And actually, there's a lot on temporal attention that you learn from the net better than I can do for sure. But in very, very simple terms, temporal attention, think of it like this, that you had the entire week that you had last week, or you've been around for as many years as what your age is. And if someone was to ask you what was the best year of your life, or what was the best day you had last week from all of last week, you'll most likely have an answer. So in very simple or conceptual terms, whenever there is a time series, whether it's days, whether it's your mood, whether it's a stock price, some days or some time frames are more important than others. And temporal attention is simply a technique which says that for every item in a time series, give it a weight that it can learn. So that's what you see here as beta 1, beta 2, beta 3, etc. And when you do that, the neural network itself can start learning which tweet or which item in the time series to give more weight to. So in short, temporal attention is nothing but an approach where you learn that what items are more important in a time series, and you do that by giving it weights that can be learned through a neural network process. Okay, I think there are two more questions that I can say, so I can take those
Okay.
quickly.
Yeah. So yeah, one of the questions is like, how do we classify which accounts post tweet that affects stocks, or rather, which tweets are important? How do we like decide which of the tweets that are available are
Right.
that more importance is to be given?
Right. So I think there's a simple and complicated answer to it. The simple answer to it is that as humans, it's very easy for us to see what made a big impact. But for neural networks, it's the whole world of explainable AI where you need to try and see, what input to a neural network led to it choosing its prediction. So there is a whole body of explainable AI research which you could always explore. But in very simple words, another important way of doing it is by looking at the attention weights. So we went over temporal attention here. If I was to look at which days, or rather which tweets were the ones that had the most amount of impact, I could see that by looking at which ones have the highest attention weights. Kind of like if I go back all the way here on this schematic, here you will see that the darker the shade of blue as a border, that is how we've represented the attention weight. So the darker the color, the higher the weight and the more impact it has towards predicting the stock price, etc. So yeah, that's the core idea in terms of um, using attention weights to try and see what is more important than the other. But then again, there is a very big field of explainable AI that sort of teaches these neural networks to focus on what is more important. The gist is we as humans don't feed it anything. We let the neural network sort of decide on its own.
I think there is one more add-on on the temporal attention only, that is it able to capture stuff like trends and seasonality, etc., in the time series?
Yeah. So I think it does to a very large extent. For example, I don't have the output to show you here, but the research paper actually does. Is there a way where I can share a link with the audience, or I don't know. Probably not, but I would suggest everyone, if whoever is interested, could just Google this name. You will find the research paper, this title of this research paper. So it does actually capture a lot of things, even things like something called the calendar effect, which at times says that stock markets are more volatile on things like Thursdays, or it can capture things like a very good example that it caught. If you look at stock prices for any stock, including this big stock overall stock market price, you'll see that it's able to capture temporal attention, can capture things like the whole fall of the stock market that happened during 2008 or during 2019 with COVID and those sort of things. So yes, in short, temporal attention is able to capture quite a bit more than what we would think initially.
Yeah, one more question is like, how could you define, like you suggested before, that MCC, you would prefer MCC, that is, usage of MCC would be better than any other point. So, like, could you explain any significant difference, or what makes it better as a standard metric? Like,
Sure. Sure. So I think anyone who does classification or works on general classification problems would also be aware of something called a confusion matrix, which is basically the number of true positives, false positive, true negatives, and false negatives. And a confusion matrix basically gives you a very, very good summary of what your classification performance is like. The drawback with the confusion matrix is that it's four numbers. So it's very difficult to compare two different models because, they could have Their confusion matrices could have different numbers, and you don't have a single number to say what is better. Now, the F1 score does not look at every single metric or every single attribute that comes into the confusion matrix. The MCC, if you look at the formula, again, I don't know how I could share the MCC. Oh, maybe I can share my screen and we'll see if that works well. Let's try that here. One sec. I'm going to share my screen and please let me know if it's visible. Let's see if this works. Okay, is my screen visible? I don't
know. It's loading.
Okay. I don't know if it will end up working or not. Still no? Okay.
Yeah, it's visible.
Right. So the MCC basically is what looks like a fairly complicated formula, but it incorporates things like the true positives, true negatives, false positives, and false negatives, which the F1 score does not do. So without going into too much maths because it'll become boring, the MCC is a more accurate representation which factors into account every single thing and is a closer approximation rather than something like the F1 score, which is just an easier approximation, right? So F1 score, you could even Google something like, I can even do it, why F1 score, sorry, why, let's just do that and see what Google says. Let's even see if this ends up giving me an answer. Right, so you can see that, I need to read this to myself to see what it says. But yeah, I think the gist is that another important thing, that's a good reminder. If you swap the two classes, so if I swap my positives and negatives, so let's say if my class, in this case, I chose stock, I chose 0, the negative label 0 to be a stock price fall, and I chose the positive label 1 to be the stock price increase. If I was to change those two labels, the F1 score would change, although the model did not change at all, whereas the MCC stays constant. So another very important thing to keep in mind is that MCC is sort of, what's the correct word, idempotent to swapping your classes, whereas MCC is not.
Yeah, so one more question we can pick is like, does a higher attention weight mean the tweet's emotion correlates with the effect on price of the stock it mentions?
Yes and no, because it's a big debate on its own if the attention weight is actually, there's no conclusive answer on it yet in the ML community. So you cannot conclusively say yes. You can definitely not say causation. However, you can say that there is a correlation for sure. And a higher attention weight definitely means that the model thinks that it has a higher correlation. Does it actually have it? There is no way of knowing it. But the model's prediction was more heavily biased by that tweet, and that's why it gave it a higher attention rate. So, in short, yes, but it's a very big debate in the ML community, and I think there is a paper. Let me try and find the name of that paper. I don't know what is the name of that paper. Attention weights. I need to find the name of that paper. If I we can take other questions, but if I find it, I'll tell all of you. Oh, the paper is called.
Yeah, we can add in the description as well.
How do I write here?
No, we'll add in the description as well.
Okay.
Or we can discuss it now as well.
Yeah, I just found the paper. It's been cited like 957 times now. The paper is called "Attention is Not Explanation." So you can understand the specifics on what it means, but more or less to your question, yes, it means and is correlated to what the model thinks. Whether that's actually true, there's no clear way of knowing that.
Yeah, one of the questions are like, we also noticed in the graph network that what kind of relations were modeled between the companies, like
Right.
in the block, right? and which of them those seem to be more important? I think there were some darker lines, and there was like
Yeah,
some more important relations between few companies. Yeah.
right. Let me see if I can pull up that paper also. Might do a better job than what I remember at least. Again, share my screen, and this time you will see the paper itself, the paper that we are all going through in this talk. So should be on my screen in like a second. Yeah. So here I think in the appendix, I don't know if we have mentioned all of it in detail, but not. But to answer your question very, very simply, here is a qualitative analysis. So this is what the output of the model is. And it shows, so here is the tweet attention, for example. The darker the color on the border of the tweet, the higher weight it had in predicting the stock price for some of the stocks that you see over here. And this is what the graph looks like. So there were many relations that were modeled. I don't have a list, it's more than 200 types of relations, but it was every single relation we could find in Wikimedia. So think of it like a knowledge graph where you model something like, oh, these two companies, one owns the other company, they have the same manufacturer, they have the same supplier. So basically any kind of relation that you can find between two companies online, we use that. And some of the ones that seemed more important, or the ones that the model gave higher weightage to, were ones where you could kind of get, I would say, let's say things like, common ownership, or basically ones where a person was a middle ground, or someone who is basically a bridge between two different companies, and ones that are like, the same owner of the same supplier and all, they didn't have that much of a weight. Again, the whole reason of choosing a graph attention network was to be able to allow the network to directly see these things rather than for us to pick any of these things. Cool. Any more questions? Anything else we should be taking up?
Well, I think we have discussed a lot of different questions, and the whole conversation was really amazing. I think time's also up now, so thank you so much for giving us so much insightful talk on this AI and finance. And I'll end this one discussion with my own one of the questions, that is like, recently when we find at different social media platforms, or different like Twitter, mostly prominently it is Twitter, and or
Mm-hmm.
even LinkedIn or even Instagram these days, that a lot of
Mm-hmm.
uh, new advancements have been achieved, right, in
Right.
NLP. So
Yeah.
how do you, I mean, like, how do you see, or what's your vision, or like key trends and
Mhm.
developments do you watch in this space?
Right. I think the easiest way for me has always been social media to look at it. So I feel like today there were even recent rumors that people will make GPT-5. I think they've now gone ahead and confirmed that they won't. The landscape changes too much every single day. It's very difficult to keep track of every single thing. But my easiest way is, I'm a big social media user, so I just keep looking at LinkedIn, Instagram, Twitter, everything that comes up. You try and stay in touch with it. Bloomberg GPT is another good example of something that came up recently. So you read some of those things and try to get a general sense of what things are up to. Attending conferences and all is another good way. But yeah, that's like roughly a gist of how I've kept in touch with some of these technologies and all that.
Yeah, so I think we can end this session, and thank you very much for
Yeah, thanks.
uh,
Thank you again for having me, and looking forward to meeting you all again. Thank you all. Bye.
thank you, sir.